So now in this video we're going to look at really about the simplest boost converter that you can make. You should just buy a boost converter if you actually need one. But in case, what it does, it takes a higher voltage and using an inductor that will provide a higher voltage at a capacitor that you charge. And if you go fast enough, you could deliver power to a load at that higher voltage and whatnot. But for this simple circuit, we are just going to measure the voltage with the multimeter because it's not the best circuit for doing this. But in any case, we have a couple resistors there, an inductor. You close the switch, current will start flowing through the components there. It takes a little bit of time, you don't notice it, but it does take a little bit of time before current starts flowing. When you open the switch, current doesn't stop instantly either. Now, it's much harder to go through the switch once you open it than to go into the capacitor right there. So current gets pumped into the capacitor. As you pump more current into a capacitor, it gets a higher voltage. If you have a load that's drawing current, of course, that's going to help hold it down. But in any case, with the multimeter, we don't really draw any current, a very, very small amount. So the capacitor voltage will just keep rising as we keep closing the button to get current to flow and then lifting the button to pump that current into the capacitor. So now we got the multimeter there. We're going to set it to V. For voltage, it's auto ranging, and I don't have to move the red probe for anything but high current right there. And it's always safe to measure voltage as long as the voltage isn't higher than what the meter can measure. So red probe, I got this alligator clip. I crimped a jumper to it. We're going to look at the capacitor voltage. We are going to look at it in relationship to ground. So for the black probe, I have another alligator clip right there. And we'll clip that and come to the negative supply rail, which is also where the capacitor is. So we have slightly less than the supply voltage of 5 volts. We can look at that right there. A little bit of current will leak through the diode, but it's such a low amount of current. There you can see the meter is already pulling the voltage down. Now it kind of leveled off, so current will flow through pretty easily at any voltage lower than this. And so I am going to hit the button. You can see that it bumped up, and each time I hit the button it bumps up a bit. It was changing the setting that it was at right there. So I can easily get it over 10 volts. Not sure exactly where it'll level off. The meter does have I think like 10 million ohms of resistance, so it does discharge it a bit right there. The higher voltage that you get, the quicker it's going to discharge, and the quicker I would have to go. But you can see if you were using like a 555 timer that is rapidly going high and low, you could pump the capacitor really quickly and maintain a voltage even with the slight load. Again, you don't have to do this. We're all done. I'm going to turn the meter off. You can just grab a boost converter. Probably costs like $1, the cheapest ones, and I bet they can handle like 1 amp of current, a lot more current than I could ever do with this rig right there. These resistors I could go lower in value, might not even need one because the inductor has some resistance, especially if you just briefly get current through it and turn it off right away. But we got the resistors just to be a little bit safer right there. Make sure that we don't have too much current flowing through. Again, this isn't made to be perfect, just the demonstration that we were able to boost that voltage. Now, this is a 4.7 microfarad capacitor. That's pretty low value right there. You'll probably see like 100 microfarad or 1,000 microfarad on the boost converter, but again, it's a lot more efficient. They can pump a lot more current into the capacitor. Its voltage will rise a lot faster, and it can provide current to a load at the same time. So keep that in mind. But otherwise, this is an informative circuit. You can see the current path for raising the voltage. To get that current flowing initially though, you need to close the switch right there to get the current flowing, and then you open it. The inductor is going to keep passing current. It's going to force current. It actually produces a voltage in order to keep current moving briefly, and that current can be pumped into the capacitor where it will store the charge. The diode there is forward bias when you open the switch to go into the capacitor, and then reverse bias so the capacitor doesn't discharge towards the lower voltage right there. So you need that capacitor as well. But in case, that's about it. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.